Hello, myself Dhanaji Mohti, presenting here my research article Perspective on Nanotechnology for Wastewater Treatments. So, wastewater is generated in industries and it is required to recycle by using the technology. So, nanotechnology is the technology that uh, we get succeeded in so many years since many years using the nano catalyst and photo nano catalyst. So in this article it is clearly described the synthesis of the effective catalyst, that is nano composites photo nano catalyst, titanium oxide with zeolite ZSM5 different compositions, that is 20, 40, 60 and 80%, and it is effective for the degradation of the phenolic derivative present in the aqueous waste in presence of uh, UV radiation. So first attempt was made for the preparation of this catalyst and its characterization, and finally how it is effective in resultant discussion. So catalyst here prepared by this simple dispersion method, titanium GSM composite at a different concentration, 20, 40, 60% prepared. So first combination of this different ratio has been prepared, and in alcohol, in ethanol, the gel formation of the road, the titanium was completely loaded on the surface of catalyst, uh, adsorbent light at the ambient temperature for 1 hour stirring. Subsequently, the gel is formed and it is dried for 100 degrees Celsius for 10 hours to remove the ethanol. Now the crystalline material was grinded and passed through the sample 20 size. Finally, the solid get calcined at 400 degree and 300 degree for 1 and 2 hours respectively. The solid material is formed at different ratio: titanium oxide 20%, 40%, 60%, uh, along with the loaded on the ZSM5 adsorbent. So it is called at 20%, respectively 80%. So characters catalyst has been characterized by the X-ray XRD method. So diffractograms of the calcium chemicals has been recorded in two delta range between 2 degree to 60 degree in of first degree with count of 60 second each point. So here the degradation of these polychlorinated phenols done in the laboratory, take the samples in 1 liter uh, capacity glass cylinder, and exposure at the different time, that is 30 minutes, 60 minutes, 120 minutes, 180 minutes, 210 minutes under the exposure of UV light of the 120 watts mercury lamp of the wavelength 350 to 400 nanometer. So, photo degradation experiment of this aqueous waste containing phenol and chlorophenol derivative when at the level of 50 ppm concentration and carried out under UV light in different compositions in at the one in 1 liter scale. So the actual solution of all the experiment has started at different ratio with 150 rpm, and the result has been carried out at different graphically. So below is the graph represent the results. The sample withdrawn at different time intervals and observer the degradation study by gas chromatography. So X-ray reflection on weight analysis of this crystalline catalyst at different concentration has been described in the below figure, and it can be observed that the Most of these degradation happen at the 60 and 80% titanium oxide supported zeolite catalyst. For 20%, 60% has given the less degradation as compared to other. Even though commercial titanium oxide and zeolite has a less degradation compared to the 60%, 80% titanium oxide has supported zeolite catalyst. Here, this graph clearly indicates the effect of titanium oxide content in the titanium oxide zeolite composite on the degradation of fluorinated compounds in aqueous wastewater at different recent time against percentage of the against percentage of the degradation. So, using the zeolite at 20% and 80% titanium oxide has given the highest degradation study against the simple titanium oxide and zeolite. So different catalyst has been used for this degradation study. So this is the reaction mechanism, how it titanium oxide works in this mechanism to degradation study, and final products get converted to the carbon dioxide and water, and this is determined by the gas chromatography study. So at the last conclusion is the titanium zeolite composite was successfully prepared using solid dispersion method, and uh, it results showing that the 60% to 80% titanium oxide Z5 composite has been greater affinity for the degradation of polychlorinated phenols in aqueous base. That's what small amount of Z5 zeolite catalyst of with the titanium protocol can help the enhanced degradation of chlorinated phenols in aqueous base and prevent the degradation of the catalyst. Here there are reference are mentioned here. So thank you for listening. This is my small research article. Thanks.